Okay, we are now talking about the Fischer projections of the monosaccharides. Now this is a little bit of a review from the previous chapter because we touched upon it at the end of chapter 12. Remember, a Fischer projection is a layout of the compound. In a Fischer projector, the most oxidized group is on top, meaning the oxygen with the double bond. If it's a ketone, it'll probably say something like this, and then a carbon with a double bonded oxygen carbon, and it keeps going down. But the double bond is still closest to the top. Another reminder, if it's an aldehyde, a lot of times it will abbreviate it CHO. That's the exact same thing as this. The chiral carbons are the intersections. So this is the chiral carbon right here. Remember, a chiral carbon is something that is different at 4 different locations. Each carbon bond has 4 bonds, or each carbon has 4 bonds. So therefore, if it has 4 different bonds, 4 different things on each bond, that means it's chiral. Now with sugar specifically, there's a lot of H's and OH's in the compound. So it starts with an aldehyde or a ketone, and then it goes to H's and OH's after that. The very last chiral carbon, which means that the second to last carbon, the last cross you're going to see, the last intersection, that's what you're going to look at to determine if it's L or if it's D. If the OH group is on the left, it has the classification of L. If it's on the right, it has a classification of D. So when we're looking at these compounds, this is ribose as a compound. Because the OH group, the last one, is on the left, it's L-ribose. When it's on the right, it's D-ribose. Look at these two enantiomers. The last OH is on the left, so it's an L. The last one here is on the right, so it's a D. So, if we're going to identify these as D or L, we're going to look at the last carbon, the last cross. So we're looking at this. Because the OH is on the left, it's L-ribose. We're looking at the very last intersection. It's on the left, so it's L. Looking at the last intersection, it's on the right this time, so that means that's a D. There you go. Now, when we're looking at glucose and fructose specifically, there's 3 monosaccharides that we have to keep in mind. There's glucose, fructose, and galactose. Here's the first 2 are glucose and fructose. They're both hexoses, which means they both have 6 carbons in them. But glucose is an aldo, which means it's an aldehyde. Where fructose is a keto, which means it's a ketone. That means that double bonded oxygen is going to be at the top for aldehyde, and it's going to be on the middle, specifically the second one, for fructose. But notice that the chemical formula are the same. So they are isomers of one another, but glucose is an aldehyde and fructose is a ketone. So if we compare them right next to each other, glucose is the aldehyde, meaning that the double bonded oxygen is at the top, whereas fructose is the ketone, which means it's on the second one. It's surrounded by carbons on either side. Now this makes a big difference when it comes to reactivity and how it looks once it's actually in a compound. Something that you might be familiar with, just as an FYI for glucose, is that when they take glucose levels of your blood, This is a really, really, really sugary drink. Back when you were a kid, you probably had icy pops, which are those plastic things full of juice that you put into the freezer, and then you eat it like a popsicle and you push it through the plastic straw. Well, think of that, but melted down in 8 ounces of it. And you have to consume this, and then the doctor or the nurse, so you as a nurse would have to do this, after an hour or two, take blood from the patient, and you would be looking at how your body reacts to the glucose. Now this is a 5-hour interval. The first time they do it, they might only do it once and have you wait 2 hours or something just to see if it's dropping back down. But if you fail that, if the patient fails that, they might have you do it for 5 hours, taking the blood level, taking blood samples every hour on the hour, so that way you can determine how well the blood is absorbing the sugar. A way to remember the difference between hyperglycemic and hypoglycemic, I think of the term hyper. Hyperactive means that a child has too much activity, while hyperglycemia means that they have too much blood sugar, where hypo means they don't have enough. So galactose, once again, is the exact same chemical formula. Also notice it's an aldehyde, just like glucose. So it's actually identical to glucose except for one thing, the 4th carbon. So 1, 2, 3, 4. On the 4th carbon, the OH is on the left. However, for glucose, 1, 2, 3, 4, OH is on the right. That's the only difference between these two compounds, but it's a very big difference, so that's the difference you have to remember. Pay attention to the 4th carbon every single time to determine if it's galactose or if it's glucose. That's the end of the introduction to monosaccharides, and we're going to talk more about this 4th carbon in the upcoming sections.